That's good.
Record data
Yeah, to record data. Why do we want to record data?
or safety.
Well, yeah, it does cover your ass. I mean, that's one. Excuse me. I don't know what's with me today. Apparently, I had a good day yesterday, and then my filter just shut off. That's a habit too.
I tried purchasing the lab book or where we write our information down, but they're right now. So
Okay.
They should be here, I think, next Monday.
Okay. So in the meantime, we're gonna pretend like you have one, because that's our bookstore rocks. All right. You know that the number of never mind. This is not difficult math. These people should have had my chemistry class, and they would never make a book ordering mistake. So we have one reason is to what did you say?
Oh,
Document
Proper documentation, cover your butt, record keeping. What other reasons?
Show how you got your answer, maybe, or I don't know.
Show your work.
We can go back to it.
Oh,
Ooh, that's
yeah.
good. So we document it. We protect ourselves from people saying we didn't do it.
Reference.
We can go back and reference it. What else? Why else will we be so interested in writing down what we did? Oh, Sydney. Was that you? Because I saw her lips move. Right? No, I didn't? No. Okay, Amy. Sorry. All right, so you're not Amy? Why did you guys switch places? Where's Amy? Oh, way in the back.
Yeah, I think we all switched from last.
Yeah, you guys aren't in the same order. Now what am I supposed to do?
Just look at our faces.
Okay, so these are good. These are all good. So we're going to document what we do. We're going to cover ourselves from possible litigation. We're going to be able to refer back to it. We're going to be able to show others what we did. What does that do for us?
Peer review.
Okay, what else does it do?
So you can replicate it?
Yeah. We don't have to reinvent the wheel every time, because I saw Sydney wrote it down, and Nathan wrote it down, and Dom wrote it down, and Brittany wrote it down. And now all of a sudden, hey, this is something. We can all do this. This is so cool, right? Childlike wonder. And hardly anybody, right, goes back and says that's why we do it, right? We do it because what we do matters, even if it seems insignificant. There are guys that collected, it came before me, these people don't do it the same way anymore, but they used to collect the data from their students just to augment the proof that what we do happens all the time, all over the country, no matter what. If we're doing the same experiment and we write down the same values, we can check with other people all over the world and say, yeah, sand can be separated from salt. Wow, all right. Research group to do that. All right, so then now we get to the next step. We have a lab book, we write in it, we write down factually what happened, not what we want to have happen. Like if I walk by and all of a sudden, oh gee, there went my experiment. I have to write down, oh, I bumped in the trash can and dropped my experiment on the ground. Oh well, that's life. Oh well, I was in the middle of my experiment and a COVID cough hit me and I spit my experiment all over the place. And then everybody had to go home for a month. All right, so, well, 2 weeks, 2 years ago. Right. So it's important, right? Your integrity is on the line every time you write something down because you wrote it down, right? And then as you improve your self-esteem and self-worth, when you make a mistake, all of a sudden the mistake doesn't matter because the mistake is all just part of doing something, right? So I write down 5, 6, oh, I can't read that. What the heck did I write? I just do 5.63, right? Just like that. Doesn't matter what I did up here. Doesn't matter if I started drawing and oh God, that's not what I want. And then I draw my little beaker, not any better. Yeah, that's horrible. But whatever. It's what it is. And the guy I substituted for yesterday, oh my God, he was like some kind of famous artist. Every little detail on his drawing, oh God, I'd love to take his class. Instead of this, what the heck is even any of that? But the point is, as you believe in yourself, and the mistakes are just part of what you're doing, you're building a pathway to believe in yourself and to give reliable data, right? It builds your integrity to do what you're doing. And that's the goal, right? Because corruption ruins us, right? Getting somewhere because you can isn't the same as getting somewhere because you did it. And it doesn't mean you shouldn't take the promotion. Take the promotion, for God's sake. Don't be silly. But then build yourself up to it, right? So we're going to write things down. When we make a mistake, we're going to cross it out with one line. We're going to write in pen, not because that's the way it's done, but because it makes you pay more attention to what you're doing. And that's the focus. And that's what does science teach us? It teaches us how to focus. It teaches us how to describe our universe. It's important stuff. It builds a knowledge base that carries us for the rest of our lives. Kind of like anything you do that takes you out of your comfort zone. But the one thing you want to be is when you're out of your comfort zone, it's like, yeah, this is good. Because I'm doing something to improve the way I negotiate this world. All right, so what else do we have? All right, we have to get the pre-labs. The pre-labs are always inside the lab itself. I'm going to post all the labs. I already told you over the weekend, I'm going to put all the labs in a module, and you can do what you want with them. Print them out, delete them, download them, delete them, forget them at home, whatever. So, here's a lab book from this class that was taught by another professor, and I have spies everywhere. So, that's it too, right? Every time you're in a class, you're building a network, whether you know it or not. If you don't build that network, that's okay, but you can. They're right here. Everybody's name's been said out loud, right? And if you constantly go through trying to make these connections, your life's going to get easier. Because somebody somewhere, I mean, maybe not, well, I don't want to be, but maybe one person you'll run into later. And you can say, hey, what's going on? And they go, oh, well, I'm president of the company. I remember you from Chem. Or, right? I'm out here digging ditches. You want to come dig a ditch today? It just all depends on your ratio. So pre-lab questions. You just write in it, right? So this person wrote pre-lab questions. And this person got an A, so it should be all right. Because it's good enough for Danae, it's good enough for me. Because Danae's who takes over for me, for you guys, if you move on to the next class. So this is one of her students' lab books. And so this is going to be the format she wants. And since she's the only one that teaches 151, it might be good that we learned her format, huh? Okay, so she's going to do pre-lab questions. You're going to put in the top corner, you're going to put experiment number, and that's going to be A. Volume of the cylinder, that's the name of the experiment. And then today's date, which is 27. Do you have paper or anything, Nate?
I did.
Oh, you already did it?
Yeah, I did.
All right. Who already did it? Oh, look at you guys. You listen to me. I did. Yeah, I know, but I say all kinds of things and nobody does them. Like I raised kids.
Remember, the pre-lab should be done in the lab notebook, not on a separate piece of paper.
Right. Today I wanted a separate piece of paper, right?
Yeah.
Yeah. And then after I proved it, you put it in the notebook. However, if you put it in the notebook because you just felt like it or you didn't know the details and you didn't feel like asking me, that's fine too. I don't care. Right? We're just working through this stuff. Okay, so pre-lab question 1. Yeah, Vince.
I did the wrong one.
Nice.
I did 1, not 8.
Okay, well, you're going to have to do A.
Yeah.
And now you can leave, what I would do in that situation, right, is you did A first, 1 first instead of A. So you just leave 1 where it is, leave yourself a few pages, and then do A, right? There's nothing wrong. There might be somebody who found fault with that, but not me, right? So when you make a mistake in your lab notebook, leave a couple of pages. No, if you write 1 or 6, but if you misinterpret an assignment, leave some pages, or just start over on the next page and say ignore previous page. Anything that helps you be able to go back and understand what you've done. Pre-lab question 1. Is it still 102 millimeters times a half equals 0.051 millimeters? Is this still pre-lab question? What did you guys get for the question?
Different.
6.58 centimeters long diameter
Yep.
gauge wire, which is 1.02 millimeters.
Ooh.
It's different.
Well, 6.58 millimeters is still the same. And
6.58 centimeters here, so we need to convert our numbers on ours.
658 millimeters.
And then 1.02 millimeters.
What, did everybody get that?
I ended up getting 53.8
Yeah.
millimeters cubed.
Yeah.
Correct.
I got 53.73.
Okay.
Can I see how you?
Yeah.
Oh, the lab.
Yeah.
I don't have one of those.
Oh, okay.
Can someone, yeah. You want to sit over there next to Alex?
Same answer as you did.
Can you share your, oh, never mind, Alex.
No, it's good.
What? Are you?
I just don't know how to
Whatever.
do it.
Yeah, okay.
It helped
Thank you for working that
for
out.
me, it helped if I showed which one was length and width. Because
Yeah.
if you know it's folding around, you know that one's going to be a circumference and one's going to be the height.
Yeah, for
So on another paper, I wish I brought it, but he did it. He drew like a paper out, and then he specified each side. That might assist you.
Yeah, just because the radius will change.
Yeah.
Because they're saying you can fold it this way, or
Or
like
long
taco
way.
and
Hot dog or
hot dog or
hamburger.
hamburger.
too loud.
Yeah. So obviously.
All right, so did it, what is our consensus answer for number 1?
53.8.
I got 53.8.
Oh, no, this is another. Yes.
Hello? Are we 53.8? Anyone get a different number?
53.7. Yeah.
Did anybody get a different number? Because, okay, so here's our first example of rounding and how we describe a measurement, right? This is perfect. What is the, oh, hold on, let me. You lose points if you don't put unit. I lose so many points not putting units up. I have to degrade myself. All right, so 53.8 millimeters. What is the range for this? What would we say? 53.8. What? This is the number that's significant, right? This is our lowest digit. We could say, if we said plus minus 0.1 millimeters cubed, that would mean that this is either 53, somewhere between 53.9 and 53.7. That's our confidence interval, okay? Well, that means that when we report this number, either one of these numbers is okay because it's within the error range of our reported digit, okay? And that's why, right, if we had, what did you have, 53.7?
My entire book was 53.739.
Okay, 739. Now, right, our if we were actually reporting this many digits, right, now our confidence interval is plus or minus 1, 2, 3. And that would be right in that range. And of course, I left off which, as you can see, even if you forget to put it in the first time, you can go back and do it. So there's no excuse not for putting the labels on just because you get in a hurry. You can go back and do it if you forget. All right. So this range, now all of a sudden, these two are out, right? it has to be 53.7 something, because we're all the way to the 1,000th if we're reporting that number. Now, we're not reporting that number because we weren't given that many digits. And that's where significant figures come in, and that's why it's so important. Because, let's just say millimeters cubed is a volume, which it is, and you were given a syringe to stick in somebody's arm, and if you gave them too much, they died, and if you didn't give them enough, they died. So you have to be right on the money exactly, or they die. People die in surgery all the time. Makes you kind of wonder how careful they are with their, no? Don't wonder?
We're very careful.
Of course you are. There's lives at stake. But that's why it's so important to have the people that have those lives in their hands, or supporting those people that have their lives in their hands, who say, hand me a syringe with this much in it, or they have the syringe with this much in it, or they're knocking a person out with a certain amount of gas, that they know those numbers inside and out. The guy who did my cataract surgery, because I'm that old now, he did all the calculations by hand. And you know what? What he winked at me and he goes, and when I had mine done, I did all my calculations. Why? Because he trusts his calculations. He doesn't trust the computer's calculations because it's an algorithm, and who knows who wrote it. So he'll do it to get a ballpark, and then he'll do the calculations himself to make sure that the calculations that were given to him by a machine, written by a fallible human being, you can actually do the math. So that's the kind of dedication people show, right? But you don't want the guy who goes, it's close enough. And there are those guys out there. So that's why people vet. Yeah.
Back to the, what confused me is it said estimate the volume, so how would then rounding to what significant figure would you round that number to?
Okay, so perfect,
If
Carl.
our largest number is.
You're like a shill for me.
Yeah,
So,
is 6.58, that's two significant figures past the decimal?
so give me the numbers you were given.
We were given 6.58 centimeters and 1.02 millimeters.
Okay, so we have what we call significant figures. Nathan.
It's 6.58, not 6.518.
Yes.
That's where I was pointing chemistry.
So, well, you're not going to. So 3, right? You used to lose points there, now you don't. 3 significant figures. 1, 2, 3. 1, 2, 3. Now, whatever we do, we can't have more than that because we only started with that many, right? Anything beyond that doesn't count. We carry it when we do the calculations, but then at the end, we report 3. Now, when we report those 3, there's a range, and calculators, which are not human beings, are programmed to give you the answer, which I'm not involved in programming them, so I don't know. But what I do know is that this range is acceptable because we're giving plus or minus 1. A lot of times, I like to do, what is that, half of that. I like to give it that much. Instead of 0.1, I like to give it 0.5. It'll give it a bigger range, right? So this is more confident than 0.5, right? 0.1 is saying, well, I'm pretty sure how right I am. And I say, well, I'm half as sure, right? Or you could be even less than, right? You could say, wow, I really don't like that. I'm here, right? And that's your basis. Like, how confident are you? And that describes a confidence interval. So the more confident you are, the less fluctuation in the numbers there are. And that's engineering, right? You build a bridge to hold a person that weighs about 220 pounds. So you're saying, I'm going to go all the way up, right? 220. My variation now is 230 to 210, right? Well, obviously it's going to hold the 210. You don't care about the lower limit. But the upper limit, that's pretty good. But if you say, right, Now your range is, so if the person weighs 220.2 or 220.0, okay, that range still doesn't matter. But now all of a sudden, a guy that weighs 230 falls through the bridge. Not so good. Right? That's why these things matter. Yeah, Tom.
I'm dead.
Only on this bridge, buddy. And it's an imaginary bridge, so the fall didn't kill you. Because you bought some tokens so that you can buy your way out and get more health.
Disperse the weight.
All right, so that's problem one.
Problem 2 was even more fun.
Okay, so what about problem 2?
Length and height.
How did you get to the, because when I did the math, I got the decimal as right after the 5 and on the 3. Did you already say why it was?
Right, because we went from centimeters to millimeters.
Oh, okay.
Yeah. So there's a 100 difference. 100 times difference.
Is it okay if your answer was in centimeters? Apparently it's the same.
Right. Well, but we want to be able to do that. Right. So for this, it's fine. Okay. How about problem 2? Did everybody get problem 1 now? And we understand how to report the answer? What about number 2? Okay, so if we fold the paper 21.59 centimeters, the volume is this. So we're gonna go height equals 27.94 centimeters. Circumference equals 21.59, right? And radius equals 21.59 centimeters divided by 2 pi. And then our volume is 2 pi r squared h, is that right?
5-1.
That's why the one, this doesn't make
Yeah.
sense.
And
I scribbled.
what do we got here?
I wrote it.
I love having this right here. This is so, I've never done this before. I actually had the thing in front of me. It's really weird. Centimeters, 2 pi squared. Yeah? Does that work for everybody? Jules, you got a slightly different answer, so what did you do?
Did you square things up?
So the way that I went to the map tutor guy at the Saturday campus, he said that circumference was equal to like pi r, so,
Uh-oh. It's 2 pi r. I'm absolutely 100% sure of the circumference.
anyway, so the way we got to do was to go ahead and find the radius by, using the circumference and dividing by pi, because we thought it was pi r,
Correct.
Okay.
but apparently it's 2 pi r, so,
So if you divide your answer by 2, you'll be right there.
yep.
Right. Okay. Well, before you square it anyway.
It's circumference divided by pi, and then that digit
Right.
is divided by 2.
Because remember, circumference is really pi d. I don't know if you remember that, but that's back when they invented the wheel and the sand was still flat before they built the pyramids. We had circumference equals pi d, and then we had to derive everything else. Ugh. It was such mind torturers. It's a good thing I learned not to be fearful or stressed out. Okay, so that's that one. All right, now we get to the important part. What is the purpose of our experiment? So we've done our little pre-lab thing, and what's the purpose? To understand the different precision levels of laboratory equipment. Okay, so we're gonna have a purpose, procedure, which is the written out stuff you're gonna do. There are 2 ways to do a lab book too. Oh my God, we're all over the place. What is with this guy today? No filter, all over the place.
In the very beginning. of
So,
this lab,
Danae doesn't
it
do it
explains
this way.
Exactly how it is to,
Oh, yeah.
yeah, in the very
That's
beginning.
Almost everybody else does.
That's what it is.
So on this side, you write down what you're gonna do. And then on this side, you write down what happened. Okay? Now, since we're preparing for today, we're not doing that, right? We're gonna do procedure. Yeah, there we go. That'll make my day.
Can't say Kobe died.
Procedure, purpose, procedure, data, right? Purpose, procedure, data. Oh, safety. Oh, I left out safety. Now, what's really popular now is to have a safety quiz associated with what we're doing. So,
Oh, great.
here's my first question. Should you insert this anywhere in your body?
No.
All right, good job. Are these made for bending into a pretzel?
No.
So please don't do that. And then here's a little kit. What's in here? Ooh, this is the magic calipers, I bet. Yeah. Magic calipers. They have these are very precise $10. So if you push the little red button, it turns on. And when you want to measure something, you open it up. And then this is a fine motor skill operation. So if I wanted to see how, with the micrometer, how this is, put this in here, you go, oh, you're providing a pencil? Very nice, Dom. Oh, I'm going the wrong way. So, oh no, it just keeps getting bigger. Okay, 10 point, and then there's two numbers after it, 10.85. 10.85, you just read the scale, right? So that's all there is to using this fine instrument. And then when you're done, you just turn it off and put it back in the box. Nice. I should have one of these. All right. Safety says don't put that in your eye either. Metal cylinders, don't drop them on your toe. Okay, so that's the safety associated with this lab. And don't crowd, no crowding. Don't be in such a hurry to get this lab done that you knock each other over, please. Personal distance. That's what's great about the 6-foot rule, is I got private space again. We're getting so many people in here that we just all crowd up. 6, so we're gonna measure these guys, do exactly what we did in the pre-lab. And we're gonna,
Great.
do we have to weigh anything? Do we have to weigh anything? Anybody?
It wants mass in grams or something.
Oh.
Pre-lab
mass in
that we
grams.
don't understand.
So, in order to get the most mass in grams with the most reportable digits, we're going to put them on the scale. First, make sure the doors are closed. Let the scale stabilize. Even if you walk up to it and it's sitting at 0, you hit tear, sets it back to 0. You let it settle down, it sits at 0. We take whatever unknown cylinder this is, composed of what unknown substance, and we weigh it. And then we give it a time to settle, and it settles. This particular one weighs 46.8725 grams, plus or minus 1 gram. Sorry, 0.0001 gram. All right, and then we take that off, close the door. If we should happen to spill, we clean it up. Because a clean lab is a happy lab, and a happy professor gets good grades. All right. So we're gonna,
I think it was top left here.
oh, this one? Right, and then we put things back, because why? Everybody tell me why.
We can find them again.
No.
No,
Why do you put things away in this class? You don't remember from yesterday?
because you're not our parents.
Ah, there it is. I am not your mom. Right? I will not clean up after you, and I will make a note. And there goes your whimsy. All right, so pretty straightforward. I'm going to walk around, check what you've done, and I don't know what I'm going to do on the notebooks. I don't really. Do you have a place for me to like digitally scratch? Measures to the 10th, we guess to the 100th. If the scale measures 1, 2, 3, 4, 5, we guess to the 10th. Always one guess beyond what we can see on the scale.
That makes sense.
Okay, we're running into our first ethical question. If we write our data down somewhere else as we're measuring, what keeps us from changing that data when we move it over? Only our ethics.
Accountability.
But if we put it down directly in the notebook, there's no ethics involved. You're just writing straight into the notebook. So today, we're fine. But that's why we want it done before we get here, so that we're just, as we measure, we're writing the data down in our book. We don't ever walk away from an instrument and not write down our data. We don't go, oh, it's 47.663, and then go back and write it down at our desk. We write it down right there as we measure. Right? Okay. Yeah.
Did it grow?
How many digits does it have past the decimal? Okay, two things, right? When you have a digital reading on any instrument, you write down all those numbers. There is no guessing. So if it has 2 decimal places, you write down 2 decimal places, like on this scale. If you're on the analytical balance, you write down all 4 digits past 0. Okay.
Part E, what is it asking exactly?
Which one?
Part B, what is it asking exactly? Just the volume of the, like, calculate the volume with this, with that information?
Right. That you can. So you're gonna first you're gonna calculate the volume, and then you're gonna weigh it, and then you're gonna calculate the density.
Oh, so I need to do density first.
I believe so.
Okay.
I think is that. So there's the volume.
Yeah,
Yeah.
I did the volume.
Right, and then you do the balance. You weigh the balance and then divide by the density.
So do, okay, so I have to find the density first, right?
Well, you find the density by your volume.
So yeah, so the mass over volume?
Right.
Okay.
Okay, so we're already gonna have our first change. Here's the change. We're not supposed to know what metal we have when we're measuring it because it's an unknown. So if we're using the densities that they gave us, I want to use those densities to compare our measurements as opposed to using the density of having you do the calculation for every density. Okay, so what we're going to do is we're going to put a little line through one of the columns and make a new column that has density, or we can add a column. So let's do this. So you have a mass that you got from the scale. Let's see if we can work through this. We want to know the density. And density is mass over volume. So we're going to use our mass, which is measured from analytical balance. And yeah, you can't read that, material teacher, whatever. And then volume is also calculated. That is going to give us a measured density. And these are great questions, right? Because when the procedure doesn't match the charts, something's wrong. And noticing that something's wrong is what we're supposed to be doing. So perfect. Okay. Measured density. Then we're going to take our measured density and compare to listed densities.
I think we fucked it up.
Okay? If you already did the other, that's fine. But how would you know unless you already guessed the metal and now you're just using what you guessed to confirm what you guessed?
That's okay.
So you were supposed to just use one cylinder for like, and measure for all the measurements, right? And
we pick different cylinders.
We switch cylinders for each one, like
So
A,
we
B, and C.
use what we think's an aluminum one, we use what we thought was a brass one, we use what we thought was a steel one. And we did all three for,
Well, that's pretty cool.
yeah, one for each.
Yeah, that's a good workaround. No, it is. I mean, you worked through it and you came to a consensus and you did it. That's awesome.
So then,
You're all lying through it?
Well, you're going to want to comment on it, but then I'm also going to want you to use your measurements to confirm your guess.
yeah,
Right? Because that's what science is. It's not, oh, I guessed this, although lately it has been. I guessed this, and then I confirm it by guessing this. That is not science. Science is I do a bunch of measurements, and then I calculate what's from those measurements, and then I compare them to the standard.
with these, after we're done with our
So my
math,
volumes must be off.
should coincide with what we
0.0056 centimeters too.
Yeah, that seems too low,
So
right?
it was.
Because if you have a 5 centimeter length,
3 times we have 3 different equations.
So
oh, you have it as a
volume-
0.5.
Because we have to
How could that be?
plug in different numbers in different equations.
Because it measured in millimeters, and then I changed it to centimeters.
Oh,
Because in here it asks,
no. Those
It
are
asks
those
for
are those are in centimeters.
it was
Right.
inches and millimeters, the one I grabbed.
There's a,
It is. It measures to millimeter, but by the time you get to 1, right?
Oh, I'm not sure.
Yeah. So you're at 5 centimeters. This is 5 centimeters. This is not 2.5 centimeters is an inch. So these numbers are centimeters.
there's the